Alright, we're going to be solving some review questions to prepare for the quiz on probability. So let's start with number 1. We've been given this wheel that contestants spin to win a prize, and the larger angles are 40 degrees, the smaller angles are 20 degrees. So why don't we add up all of the larger angles, these darker colored ones. 1, 2, 3, 4, 5, 6. Looks like 240 degrees are the shaded sectors, no prize. And that leaves all the white areas, 1, 2, 3, 4, 5, 6. 6 times 20, that's 120 degrees where you do win a prize. Alright, let's come down then to part A. It says, what is the probability you will not win a prize? Well, we just counted that there were 6 regions of 20 degrees each that added up to, 40 degrees each, that added up to 240 degrees out of 360. So 240 out of 360 will reduce to 2 out of 3. Which I hope makes sense. If we look at any one pair of white and dark together, if this is 20 degrees and that's 40 degrees, we can see that in any one pair of these two, 2/3 of the space is taken up by the no prize shaded sector. Part B, will win a holiday in Greece. GH. Alright, I can see GH here, I can see GH here, and that's it. So that's a total of two 20-degree regions. So that's 40 degrees off the 360 degrees in a circle, which reduces to 1/9. How about part C? Will win a washer-dryer, given that he knows he has won a prize. Alright, if we know that we have won a prize, then instead of looking at all 360 degrees in the wheel, we're only going to be looking at the regions that we have been given. We have definitely won a prize. Remember that there are 120 degrees, those 6 white 20-degree regions. That's 120 degrees where he has won a prize. Of those 120 degrees, how many of them are a washer-dryer prize? And I can see that there's a 20-degree region there and another 20-degree region there. That's a total, and another one here too. A total of 60 out of 120. So given that he's won a prize, he's got a 50% chance of it being a washer-dryer, which I suppose makes sense if you consider that there are 1, 2, 3, 4, 5, 6 prize regions, all of equal size, and 3 of those 6 are the washer-dryer. Well, you would expect a 50% chance. And lastly, part D, will win a holiday in Greece or a washer-dryer. Alright, now in an OR question, I'm immediately thinking golden rule. So this should be equal to the probability of winning a holiday in Greece, which we've already done in part B. That was 40 over 360. To this we will add his probability of winning a washer or dryer. And so washer or dryer, we can see that that's 60 over 360. And then I'm supposed to subtract the overlapping region. Remember the and? But of course, having a holiday in Greece or winning a washer-dryer, these are mutually exclusive events. They cannot both happen at the same time because these regions never overlap. As a result, we are subtracting 0. It's impossible to both win a holiday in Greece and a washer-dryer at the same time. And we end up then with 100 over 360, which will reduce to 5 over 18. If I can fit that in here, 5 over 18. And we're done on number 1. Number 2. Of a group of 5 students, 2 will be selected to visit the United Nations. The 5 students are John, Maria, Raoul, Henry, and Susan. So I need to find all of the different possible combinations of students that could go to the United Nations, or at least I need to find the number of different possible combinations. Well, it says with the aid of a tree diagram. I know how to use tree diagrams. So we have to select 2 students. Remember that when we're selecting 2 at the same time, you can break that activity down into first selecting 1 and then selecting a second one. So why don't we select our first student? This is now going to be a sequence of selections, isn't it? We're first making a selection between 5 different students to see who will visit United Nations. And once we've selected one of these 5 students, then there's going to be 4 left to select. So I'm going to have 4 branches coming out of each of these, and you can imagine 5 branches, and each one has got 4 smaller branches coming out of it. That gives me a total of 20 possible outcomes, doesn't it? Alright, part B. Find the probability that both Maria and Susan will go on the trip. Alright, this tree diagram is obviously too small for me to really use particularly well. So why don't I create a new diagram that says that either we'll have Maria going on the trip, Susan going on the trip, or let's just call them somebody else. I'll call them Mr. X, somebody else. And so at the beginning, there's a 1 in 5 chance of Maria, a 1 in 5 chance of Susan, and a 3 in 5 chance of it being one of these other 3 kids. And now once that selection is done, Maria's already been taken, so we're only interested now in Susan or somebody else. Or if Susan's been taken, then we're only interested on whether it's Maria or somebody else. And look, if somebody else has been taken, it's impossible for both Maria and Susan to make it, so we're not even interested in looking to see that possibility anymore. So the only ones we're interested in are this one right here, where Maria and Susan went, and this one right here, where Susan and Maria went. Okay, now remember, we've already selected one of the 5 people, so there's only 4 people left to choose from, one of whom is Susan. So 1 out of 4 for Susan, and because Maria was chosen, the other 3 people that we don't want to go are still left to choose from out of the 4. A quarter plus 3/4, yes, equals 1. And we'll have the same thing down here. Maria is 1 name of the remaining 4, someone else is 3 names of the remaining 4. Let's multiply these probabilities now. Maria and Susan, that's 1/5 times 1/4, gives a 1 over 20 chance. Or we've got Susan followed by Maria, that's 1/5 times 1/4 as well, giving me a 1 over 20 chance. And now then we need to add these 2 possibilities together, because these are the 2 final probabilities that do meet our event of both Maria and Susan going on the trip. 1 over 20 plus another 1 over 20 is going to give me 2 over 20, which of course reduces to 1 over 10. Number 3. A bag contains 2 red, 3 yellow, and 5 green sweets. Without looking, Mary takes a sweet out of the bag and she eats it. Obviously, she's not replacing it if she's eaten it. And then she takes out a second sweet. So it looks like we're going to have a tree diagram here, because she's making a sequence of selections. She's first selecting a sweet, which is either red, yellow, or green. And then she's not replacing it, and she's taking out another one that is red, yellow, or green. Okay, now then, let's fill in the probabilities. We have a total of 10 sweets, so that's kind of convenient when something's over 10. It's very easy to express them as decimals, which takes up less room on my diagram. And so she's got 2 out of 10 red, that's 20%, or 0.2, 0.3, and 0.5, 50% of them are green. Now for the second selection, of course, there's now only 9 left in the bag, so I guess, oh yeah, maybe that was a mistake. Perhaps I should have written it as fractions in the first place. Oh well, there's only 9 left in the bag. If I've already chosen a red, then obviously there's only 1 out of 9 chance, only 1 red left in the 9 remaining sweets. There's still all 3 yellows, and there's still all 5 greens. Similarly, if I've chosen a yellow first, then both my reds are still in the bag. I've got only 2 yellows remaining, and I've got all 5 greens. And down here, I've got all of the original reds, all of the original yellows, but I've taken one of my 5 greens, leaving only 4 of them. 4 out of 9. Sorry about how small this is. Okay, here we go. We're ready for the question. A. If the first sweet is green. So you've been given the information that the first sweet is green. So we've already moved along to the green part of the diagram. If the first sweet is green, what is the probability that the second sweet is also green? Well, because we know the first one is green, we've moved here. What's the probability of the second one being green? At this stage, it's 4 over 9, isn't it? Because I've only got 4 green sweets left, and there's only 9 sweets left in the bag. Part B, if the first sweet is not red, what is the probability that the second sweet is red? Now that's a significantly more difficult question. The first sweet is not red. Alright, so we're definitely not going to be moving along this part of the tree diagram. And so I can in effect get rid of that. What is the probability that the second sweet is red? Okay, well, that's obviously going to mean involving these two possibilities. So let me just write this down in probability notation. What is the probability that the second sweet is red? So let's write that I get a red on my second selection, given that the first sweet was not red, meaning it must have been yellow or green. So given that I've got a yellow or green on my first selection. Well, according to the conditional probability formula, this is going to be equal to the probability that both of these events have occurred, meaning that I got a red on my second and I got a yellow or a green on my first, over the probability of the given amount, which is that I got a yellow or a green on my first. Well, I'm going to need a little bit more room to do this. So let's come over here. The probability that I got a red on my second and a yellow or a green on my first, there's two ways that can happen, right here and right here. Let's work that out then. I should have written it as a fraction in the end, shouldn't I? 3/10 times 2/9 plus 5/10 times 2/9. And that gives me a total of 6 over 90 plus 10 over 90 is 16 over 90. Meanwhile, in my denominator, I've got the probability of getting a yellow on my first draw or a green on my first draw. And I can see that the total probability of that occurring is 0.8. And so I'm just going to put a 0.8 on the bottom here. And I can express 0.8, if I like, as something over 90 to get a common denominator. Happens to be equal to 72 over 90. Or I suppose we can just reach for the calculator at this point. So anyway, I'll cancel my 90s. I get 16 over 72, which reduces to 2/9. Or another way, I suppose, is reaching for the calculator. We say, all right, I've got, let's go all the way back from here. I've got 3/10 times 2/9, and then to this I need to add 5/10 times 2/9. That gives me this number. I'll divide it by 0.8, and then I'll express my answer as a fraction, although I guess I could leave it as 0.222, but to express it as a fraction I'll press Math and Enter. To express my answer as a fraction, there it is, 2/9. Alright, I'll continue in the next video with subsequent questions.